This is the Year 12 Maths Methods VCAA VCE 2017 Official Exam Paper 1. Short answer question 9. Question 9. The graph of f, where the domain is between 0 and 1, as shown on the diagram here, is f equals square root of x, 1 minus x is shown below. A. Calculate the area between the graph of f and the x-axis. To find the area between the curve and the x-axis, we just simply use calculus, integration. And that comes out to integral of the equation of the curve, which is square root of x, brackets 1 minus x, close brackets, dx between x equals 0 and x equals 1. Then to integrate this, we need to we got to remove that square root umbrella by using the Year 9 Easy Rule. So that comes out to square root of x is x to the power of a half times everything inside the brackets, dx. So therefore, we say x to the power of a half times 1 and x to the power of a half times x. And that comes out to x to the power of a half times 1 is x to the power of a half minus, what's x to the power of a half times x to the power of 1? That comes out to x to the power of 3 on 2 dx. Then we are in a position to integrate. So we integrate by doing the customary procedure of adding 1 to the power divided by a half plus 1. And you do the same thing here. You add 1 to the power and divide by 3 on 2 plus 1 between 0 and 1. And then we further clean it up. What's a half plus 1? It's 3 on 2. So a half plus 1 divided by 3 on 2. What's 3 on 2 plus 1? It's 5 on 2. What's 3 on 2 plus 1? It's 5 on 2. Between 0 and 1, 0 and 1. Then you further clean it up by saying x to the power of 3 on 2 divided by 3 on 2 using grade 5 fraction theory, where they teach you that if you got a fraction divided by a fraction, you keep the first fraction the same, x to the power of 3 on 2, and you times it, and you upside down the second fraction, which is 2 on 3, minus x to the power of 5 on 2 divided by 5 on 2 becomes 2 to the power of 5, x to the power of 5 on 2, and between 0 and 1. Then we put in x equals 1 here, okay, x equals 1 here. Then we put in minus, as we normally do in the middle of these integration questions, and then we put in x equals 0, and that comes out to 2/3 times 0 to the power of 3 on 2 minus 2/5 times 0 to the power of 5 on 2. Then we further clean it up. It's going to be 2/3 times 1 to the power of 3 on 2. 1 to the power of anything is 1 minus 2/5 times 1 to the power of 5 on 2. Like we just said, 1 to the power of anything is 1 minus 2/3 times 0. 0 to the power of 3 on 2. 0 to the power of anything is 0 minus 2/5 times 0 to the power of 5 on 2. Again, 0 to the power of anything is 0. And then that comes out to 2/3 times 1 is 2/3, minus 2/5 times 1 is 2/5, minus 2/3 times 0 is 0, minus 2/5 times 0 is 0, and that comes out to 2/3 minus 2/5. What's that? Using grade 5 fraction theory, where they teach you that when you've got a fraction minus a fraction, you make both denominators the same. So what's the lowest common denominator here? 15. So change that 3 to 15. How? By timesing it by 5. Like they teach you in grade 5 fraction theory, whatever you multiply the bottom by, you multiply the top by. And then to make that 5 go to 15, you times it by 3. So again, times 3 times 3. And it comes out to 2 times 5 is 10. 3 times 5 is 15, minus 2 times 3 is 6. 5 times 3 is 15. And 10 minus 6 is 4 on 15. And question 9a has been done. Now we go to question 9b. 9b says the following. For x in the interval 0 to 1, show that the gradient of the tangent line to the graph of f is 1 minus 3x on 2 square root of x. Well, in this, like you can see, I've redrawn this diagram over here. And what they want you to show in this question is that if you draw a green tangent line anywhere along this black curve here, for example here, then you've got to show that the gradient of this green tangent line is always going to be equal to 1 minus 3x on square root of x. I repeat, you've got to show that the gradient of the tangent line is always going to be equal to 1 minus 3x on 2 square root of x. Now, how do you answer this question? By taking the following path. By saying that at x equals 1, at any point x equals 1, the gradient of the black curve at x equals 1 is equal to the gradient of the green tangent line at the same x equals x subject 1. Now, what's the shorthand mathematical professional way of saying gradient of black curve? It's to say dy dx at x equals x1. And that's equal to the gradient of the green tangent line at x equals x1. To work out this question, we've got to work out dy dx. So we've got to now do a little side calculation where we find dy dx. Now, we know from the question that the black curve has got the equation y equals square root of x, 1 minus x. So we can find the dy dx by using the product rule, because it's function times function. And the product rule, as you should know by now, is y equals u times v, then dy dx equals u dash v plus uv dash. Well, what's u? It's a square root of x. So u equals x to the power of a half. So u dash equals a half x, a half minus 1 is negative a half. Now, then what's v? V is equal to 1 minus x, and v dash would be, what's the derivative of 1? 0. Forget about it. And negative 1x, the derivative of negative 1x is negative 1. Therefore, the overall derivative, according to the product rule, is dy dx equals u dash v plus uv dash. So therefore, f dash is equal to u dash is equal to a half x to the power of negative a half times v is equal to 1 minus x plus u is x to the power of a half times v dash is negative 1. Now we need to clean it up a bit. A half, well, that's a half. Let's get rid of that negative power by using one of those Year 9 easy rules, and that becomes 1 on x to the power half times 1 minus x can be written as 1 minus x divided by 1 plus x to the power of a half times negative 1 is negative x to the power of a half. And that becomes the following f dash x using grade 5 fraction theory. A half times 1 on x to the power of a half times 1 minus x on 1 becomes what? 1 times 1 is 1. 1 times 1 minus x is 1 minus x. 2 times x to the power half is 2 x to the power of a half times 1, which remains as 2x to the power half minus x to the power of a half. And that becomes f dash is equal to, let's get rid of those fraction powers by using one of those Year 9 easy rules. 1 minus x, 2x to the power half is square root of x minus x to the power half is square root of x. Then what we can do is reduce these two separate fractions, so to say, into one fraction by doing the following. We got 1 minus x on 2 square root of x minus square root of x is square root of x divided by 1. And then we can combine these two fractions together by making the denominators the same. How? Well, I rewrote this black writing over here. And to make that one go to 2 square root of x, we times it by 2. Sorry, square root of x. I had something in my throat. We times it by 2 square root of x, and you times the top by 2 square root of x. And that becomes 1 minus x on 2 square root of x minus what square root of x times 2 square root of x? It's 2x. 1 times 2 square root of x is 2 square root of x. Then, because we got fraction minus fraction, and they've both got the same denominator, we can combine these two fractions into one by saying the following. 1 minus x minus 2x on 2 square root of x. It's 1. Negative x minus 2x is negative 3x on 2 square root of x, and we have shown that is the gradient of the green tangent line, no matter where you put the green tangent line along the black curve, as requested by the question. Now we move on to the next sub-question. The next sub-question is question 9c. What is question 9c about? The edges of the right-angled triangle ABC are the line segments AC and BC, which are tangent to the graph of F, and the line segment AB, which is part of the horizontal axis, as shown below. Let theta be the angle that AC makes with the positive direction of the horizontal axis, where the angle theta is between 45 degrees and 90 degrees. C. Find the equation of the line through BC in the form y equals mx plus c for theta equals 45 degrees. So basically it's this, that I've redrawn basically this diagram over here, as you can see. Now, in this question, basically in the final analysis, they want you to find the equation of that green tangent line BC. how do you find the equation of that green tangent line BC? Well, by knowing that to find the equation of any green tangent line, we use this formula here, y minus y subscript 1 at that intersection point there between the green tangent line and the black curve, m subscript t, the gradient of the green tangent line, x minus x1. So let's first find m subscript t. Well, m subscript t is equal to the gradient of the green tangent line at x equals x1. But when you think about it, that is also equal to the gradient of the black curve at x equals x subscript 1. Now, what's the shorthand professional way of saying gradient of a black curve? It's to say dy dx at x equals x1. Now, we saw in an earlier calculation that no matter what, wherever you put the green tangent line on the black curve, the gradient of the green tangent line will always be 1 minus 3x on 2 square root of x at x equals x1. Also, from the above graph, we can see that the green tangent line BC is 135 degrees to the positive x-axis direction. How so? Well, in the question, they say very clearly that that angle there is 45 degrees. And they say also very clearly that it's a right angle triangle ABC. So that's 90 degrees. Because, as you know, the sum of all angles in a triangle is 180 degrees, then that remaining angle in this triangle ABC must be what? It must be what? Well, it's 45 degrees plus 90, 145 degrees. So therefore, that angle there must be 180 degrees minus 135 degrees, 45 degrees. And then that outside angle must be what? Well, because, as you would know, if you add up all the angles around a straight line, the angles add up to 180 degrees, then therefore that angle there will be 180 minus 45 degrees, 135 degrees. So as a result, we know that the angle between the green tangent line BC and the positive x direction is 135 degrees. From that, we can also work out the gradient of the green tangent line BC by using the fact that the gradient of any line is also equal to tan theta. So the gradient of that green tangent line BC is equal to tan theta, and that's equal to the gradient of the green tangent line is equal to tan. What's theta? Theta is 135 degrees. And therefore, the gradient of the green tangent line MT is equal to what's tan 135 degrees? -1. Therefore, by combining the above, we obtain the following. That we know at this point that the gradient of that green tangent line is equal to -1, -1. And also we know that the gradient of that green tangent line is also equal to 1 minus 3x on 2 square root of x. 1 minus 3x on 2 square root of x. Now we've got one equation with one unknown, which is x, and now we've got to find what x is. How? By taking the following path. Find x. Well, multiply both sides by 2 square root of x, and you get -2 square root of x, and that's equal to 1 minus 3 minus x. That comes out to negative 2, and that's equal to what? Well, 1 minus 3. Now, x can be written as square root of x times square root of x. Why do we take that path there? Well, it will become clear fairly shortly. Now, to make it a little bit easier to our eyes in the subsequent calculations, wherever you see square root of x, we make it equal to a. So therefore, negative 2 square root of x is a is equal to 1 minus 3. That's square root of x is a times square root of x is a. And that's equal to negative 2a is equal to 1 minus 3a is 3a squared. Then you put everything on the left-hand side, and it comes out to 3a squared minus 2a minus 1 equal to 0. Now that looks like a relatively somewhat simpler, in some ways, quadratic equation. So as a result, we could hopefully be able to factorize it. Well, let's see. Because it's got a 3 in front of a squared, we say 3 times negative 1 in negative 3. Then find the factor of the negative 3, which are negative 3 times 1, and also, of course, 3 times negative 1. But then you've got to ask yourself this question here. Which factors of negative 3 will add up to negative 2? They will be negative 3 plus 1. So therefore, you say 3a squared. That negative 2a gets replaced with negative 3a plus 1a minus 1, and that's equal to 0. Then because we got 4 terms, we can perhaps factorize it by grouping it 2 and 2. So therefore, I rewrote all that out here again, and I grouped it 2 and 2. And then you can factorize these first 2 terms. What's the common factor between 3a squared minus 3a? It's 3a. Take out 3a, and when you take out 3a, that 3a squared becomes a minus, when you take out 3a, that 3a becomes 1. Then you factorize the second the 2 terms by taking out, so to say, the common factor, which is plus 1. You take out plus 1, and that becomes a. And when you take out plus 1 from negative 1, it remains at negative 1. And that's equal to 0. And then because within these brackets we got a minus 1, and because within these brackets we got the same a minus 1, you can do the following trick. It comes at the 3a plus 1, and a minus 1 equals 0. Then we can use the null factor law that says that every time you got brackets times brackets equal to 0, then we can say 3a plus 1 equal to 0, and a minus 1 equal to 0, and then get a by itself, and it gets it to a equal to 1/3, and a equals 1. But hold on, we know that in actual fact, a is square root of x. So as a result, wherever you see an a, you put square root of x, and that's equal to negative 1/3. And wherever you see an a, you put square root of x, and that's equal to 1. Because we've got to find x, then we've got to get rid of those square roots. How? By squaring both sides. So I rewrote that green line down here again, and I squared both sides, and it gets it to x equals, what's 1/3 squared? It's 1/9, And also I did the same thing here. I've got to find x for that. How? By rewriting that green line down here, and I square both sides. And square root of x squared is x, and it's equal to 1 squared is 1. So we get x equals 1/9 and x equals 1. Well, are both of these x values possible? Well, no. Why? Because if you look at the graph for the tangent line BC, it's feasible to say that the intersection point between the green tangent line BC and the black curve is at x equals 1. But as you can see from the graph, it's not feasible to say that the intersection point between the green tangent line and the black curve over here will be at x equals 1/9. So therefore, x equals 1/9, by looking at the graph, you can see clearly is not possible. So therefore, it's just x equals 1. Now, so at which point, we now know that the intersection point between the green tangent line BC and the black curve is at x equals 1. So the coordinates at x equals 1 will be 1, 0. So therefore, x1, y1 will be 1, 0. And we also know that the gradient of the green tangent line BC is -1. So therefore, we can now find the equation of the green tangent line as requested by the question. Therefore, equation of the green tangent line is y minus y1 equals mt, x minus x1. So therefore, y minus, what's y1? Y1 is 0, as you can see on this diagram, equal to mt. Mt is the gradient of the green tangent line, which is -1, -1. X minus x1 is 1. And it's going to be y minus 0 is y equal to negative times x negative x. Negative times -1 is positive 1. And therefore, the equation of the green tangent line is y equal to x plus 1. And that's the end of question 9c. Now we move on to question 9d. What is question 9d about? Question 9d says the following. Find the coordinates of C when theta equals 45 degrees. So, in this question 9d, they're talking about this graph here that we've seen now a number of times in one way or another. And I've redrawn this graph over here. Now, they tell us that that angle there is 45 degrees, and it's a right angle. And of course, as we said before, that angle there is also 45 degrees. We know from question 9c that the equation of the line BC, y subject BC, is equal to negative x plus 1. Now, from that information, they want us to find the coordinates of point C. How do you do it? Well, it's this. Firstly, they tell us in the question very clearly that that angle there is 45 degrees. So what is the gradient of that green tangent line AC? Well, the gradient of any line is tan theta, where theta is the angle between the line and the positive x direction, which in this case is 45 degrees. So therefore, the gradient of the line AC will be tan 45 degrees. So therefore, the gradient of the green tangent line AC equals what's tan 45 degrees? It's 1. So we now know that the gradient of the green tangent line is AC. But from that information there, how do you find the coordinates of point C? Well, the overall strategy for this question is the following. Number one, step one, to find the coordinates of point C, we need to find equation of the green tangent line AC, that is YAC. Step two, then to find coordinates of point C, we need to equate the equation of the green tangent line AC with the equation of the green tangent line BC. That is, we need to find the equation of the green tangent line equal to the equation of the green tangent line BC. Now, we know from our earlier calculation the equation of the green tangent line BC, but we don't know at this point the equation of the green tangent line AC. So now at this point we've got to find the equation of the green tangent line AC. How do you do it? And that's what I say here. Therefore, let's find equation of the green tangent line AC. That is, let's find YAC. Well, we saw in question 9b that the gradient of the green tangent line, no matter where it is along the black curve, will always be equal to 1 minus 3x on 2 square root of x. So as a result of that, we can say that if we draw any old green tangent line AC along here at any old point x1, y1, then we can conclude from that that the gradient of the green tangent line is always going to be equal to 1 minus 3x on square root on 2 square root of x. But we also know from what the question tells us that because that angle there is 45 degrees, we also know that the gradient of this green tangent line is also equal to 1 in this particular case. So therefore, from the above graph, we can say the following, that the gradient of the green tangent line AC is equal to 1, as what we just said, but also the gradient of the green tangent line AC is also equal to 1 minus 3x on 2 square root of x, as we've just said also. So therefore, here we got basically one equation with one unknown, which is x. So now we've got to find what x is. What's x? That is, what's x1? Well, what's x? The way we work out that is to take the following approach. That we now know that for this particular sub-question, 1 equals 1 minus 3x on 2 square root of x. So now we're going to find what x is by taking the following approach. Multiply both sides by 2 square root of x, and then we get 2 square root of x equals 1 minus 3x. Then to find x, we take the following part. We say 2 square root of x equals 1 minus 3. X can be written as square root of x times square root of x. Now, to make it a little bit easier to our eyes, because we got square root of x here, square root of x here, square root of x here, we can make square root of x equal to a. And so wherever there's a square root of x, we put a. Wherever there's a square root of x, we put a. And that comes at the 2a equal to 1 minus 3a squared. Now we put everything on the left-hand side, and you end up with 3a squared plus 2a equals 1. Now, factorize that, all right? You factorize that. One way of factorizing that is to say the following. Because we've got a 3 in front of a squared, we say 3 times -1, which is -3. Then we've got to find the factors of -3, which are 1 times -3 and 3 times -1. And then we say, which one of the factors of -3, when added together, give you +2? Well, it will be 3 minus 1. So therefore, our magic numbers are 3 minus 1. So therefore, we have the following. We have to factorize 3a squared plus red 2a minus 1 equal to 0. Because our magic numbers are 3 -1, then we replace the red 2a with 3 -1 by saying the red 2a is plus 3a minus 1a. And we end up with 3a squared plus 3a minus 1a minus 1 equals 0. Because we got 4 terms, we can factorize 4 terms by grouping it 2 and 2, as you can see here. And then we can take out the common factors from the from the first 2 terms. When you take out 3a, it comes out to 3a brackets. That 3a squared becomes a plus 3a becomes 1. And then you can factorize the second pair of 2 terms by taking out the common factor, which is basically -1. And that comes out -1a becomes a. And when you take a -1 from -1, becomes +1 equals 0. Again, because what's inside these brackets is inside these brackets, you can do the following trick. 3a minus 1 and then a plus 1 equal to 0. Then using the null factor law, we can say 3a minus 1 equals 0 and a plus 1 equals 0. Find a. So 3a equals 1 and a equals 1/3 and a equals -1. Okay, we now know what a is. But we know that in actual fact, a is equal to the square root of x. So wherever there's an a, you put square root of x. Wherever there's an a, you put square root of x. Because we're going to find x, then get rid of those square roots by squaring both sides. So you square both sides here, and you square both sides here. And you get x equals 1/9 and x equals 1. Now, the thing is this, are both x values possible? Well, in this particular case, no. Why? Because as you can see from the diagram here, the green tangent line AC is on this side. And if that's x equals 0 and that's x equal to 1, then clearly the intersection point between the green tangent line AC and the black curve won't be at x equals 1. So x equals 1 is out, but it's forcible and it's feasible to see that, that the intersection point between the green tangent line here and the black curve here is x equals 1/9. So it's just going to be x equals 1/9. So therefore x equals 1/9 and therefore x of 1 is 1/9. So we get the following. So therefore we will have the following. As you can see, I've redrawn the diagram, and now we know that the intersection point between the green tangent line AC and the black curve is x sub 1 equals 1/9. Now we're going to find the corresponding y sub 1 intersection point. How? We find y sub 1 by putting x equals 1/9 into the equation of the black curve. And that's what I say here. Find y sub 1 by putting x equals 1/9 into y equals square root of x, 1 minus x. And when you do that, you put x equals 1/9 here, and you get y sub 1 equals square root of 1/9 brackets 1 minus 1/9, and then y1, square root of 1/9 is 1/3. 1 minus 1/9, if you use grade 5 fraction theory, comes out to 8/9. And therefore, 1/3 times 8/9 is 8/27. As a result, we now know that y1 equals 8/27, and as a result, we have the following. That y1 is 8/27. Okay. Now we can find the equation of the green tangent line AC by using y minus y1 equal to mt x minus x1. So y1, as we've just seen, is 8/27, and x1, as we've just seen, is 1/9. So therefore, y minus 8/27 equals 1 times x is x, 1 times -1/9 is -1/9. Now we're going to find y. That is, get y by itself. So therefore, y equals x minus 1/9. Bring the negative 8/27 onto the other side, plus 8/27. Then y equals x. Then using grade 5 fraction theory, where you got a fraction plus a fraction, make the two denominators the same. So therefore, 1/9 becomes 3/27 plus 8/27. So therefore, what's -3 plus 8 is plus 5/27. So y equals x plus 5/27. So at this point, we now know that the equation of the green tangent line AC is equal to y subject AC equals x plus 5/27. So therefore, we have the following. As you can see, I've redrawn the graph here again, and we now know that the equation of the green tangent line AC, that is YAC, is equal to x plus 5/27. From earlier calculations in question 9C, we know that the equation of the green tangent line BC is equal to -x plus 1. So as a result, we're in a position to work out the coordinates of point C. How? Well, by equating the equation of the green tangent line AC with the equation of the green tangent line BC. And that's what I say here. Now we can find the coordinates of point C by equating the equation of the green tangent line AC with the equation of the green tangent line BC. That is by working out y subscript AC equal to y subscript BC. And therefore, what's the equation y subscript AC? We just worked it out as being x plus 5/27, and that's equal to what's the equation of y subscript BC with its -x plus 1. Here we got one equation with one unknown, which is x, so we can find what x is. So to find x, we can put all the x's on one side, x, positive x, and that's equal to, and we can put all the constant numbers on the other side. So that will give us positive 1, and when we put that positive 5/27 on the other side, it becomes minus 5/27. X plus x, of course, 2x, and that's equal to 1 becomes 27/27 minus 5/27. So therefore, 27 minus 5 is 22/27. 2x equals that, and therefore, find x, get x by itself. How? Well, we got 2 times x here, equal to 22/27. Then to get x by itself, you get rid of that times 2 by saying, what's the opposite times 2? Divide by 2. So we divide by 2, shown in red on both sides, and we get x is equal to 22 on 27 divided by 2. Then using grade 5 fraction theory, what 22 on 27 divided by 2? It is 22 on 27 divided by 2 is 2 divided by 1. And then fraction divided by fraction, keep the first fraction the same. And it comes out to 22 on 27. Change the divide to times. And upside down the second fraction, 1 on 2. And therefore, I rewrote that black line out here again. Like they teach you in grade 5 fraction theory, when you go fraction times a fraction, then you've got to ask yourself, is there a common factor between one of the bottom numbers and the top numbers? Yes, there's a 2. So 2 goes into 2 and 22. So divide by 2, divide by 2. You get to 22 divided by 2 is 11 on 27 times 2 divided by 2 is 1. And therefore, it comes out to x equals 11 on 27 times 1 on 1, which is 11 on 27. Therefore, we have the following. That we now know that the x-ordinate of point C is 11 on 27. With that information, we can now find the corresponding y sub C coordinate of point C. How? Well, like I explained here, you can find y sub C by putting x equals 11 on 27 in either one of these green tangent lines here. But in my opinion, it would be a little bit easier to find y sub C by putting x equals 11 on 27 into the equation of the green tangent line, y sub BC equal to negative x plus 1. And that's what I say here. Now we need to find y sub C by putting x equals 11 on 27 into y sub BC equal to negative x plus 1. And that becomes y sub C equals negative x is 11 on 27 plus 1. Now we've got to work out what y sub C is using grade 5 fraction theory, basically. Negative 11 on 27 plus 1, which is 27 on 27. And then what's negative 11 plus 27 is 16 on 27. And now we know that y sub C equals 16 on 27. So y sub C is equal to 16 on 27. So therefore, we now know that the coordinates of point C are going to be x is 11 on 27 and y is 16 on 27. So as a result, we have answered that question completely, and we have completely answered the whole of question 9.